Alright, so chapter 6 is all about functions, with different kind of things that you can do with functions, in particular square root or radical functions, and we'll also talk about cube roots and things like this. 6.1 is on doing different operations with functions. Basically, the four basic math operations are adding, subtracting, multiplying, and dividing. So we'll learn how to do that, and then also something called finding the composition, or composing functions together. Okay, so let's talk about adding, subtracting, multiplying, dividing. First of all, a function basically means that every input or x value has at most one output or y value. That's what we mean by a function. The way that you add these are exactly as you would expect. So for example, f plus g, that's another way of saying the f of x function plus the g of x function. The f of x function is right here. It's x squared minus 4. And the g of x function is right here. It's plus 2x plus 1. And I just put the parentheses there to show that they're two different functions. X squared doesn't have any like terms. We have minus 4 plus 1. That's the same as minus 3. And then we still have that plus 2x. So that would be as much as we can add right there. Okay, same thing if we were to subtract them. So if we now subtract these two functions, this is still our f of x function. And this time we are subtracting this g of x function. We need to put that whole thing in parentheses. Then what we end up doing is distributing this negative to what's inside, so that becomes minus 2x minus 1. We have x squared minus 2x, and then we have minus 4 minus 1. That becomes minus 5. So that is how you would subtract them. Okay, this is just a note about a term that's important with functions, something called the domain and range. So the domain is the set of all things that I could plug in for x, and the range is the set of all numbers that I could get out for y. Okay? When you are doing things like what we're doing, you're adding, subtracting, multiplying, or dividing, the domain consists of the intersection of these two functions. So here's a simple example. Suppose that the domain of f of x were 2, 3, and 4. And let's say the domain of g of x were equal to 3, 4, and 5. The domain for both of them, okay, like for example, the domain for f plus g, or f minus g, or f times g, or anything like that, the domain for both of them would be the intersection. So if we look at these two functions, the intersection would be what they both have in common. They both have a 3 in common. They both have a 4 in common. So the domain for any of those new functions would be 3 and 4. Just the things they have in common. Okay, the other thing is when we're dividing numbers, we'll talk about this in a sec, you can't have a denominator equal to 0. You're not able to divide something by 0, so we'll see how that looks here. So f times g, well here's f right here, x squared plus 7x plus 12. Okay, that's f of x, and we are multiplying it times g of x, which is right here, so times 3x minus 4. I always find it easiest when you're multiplying things to make kind of a box for yourself where you put the functions that you're multiplying, one goes on the top, one goes on the side, and then we just make a column for each and a row for each, and then we fill in the box. So x squared times 3x is 3x cubed, 3x times 7x is 21x squared, 3x times 12 is 36x, and then negative 4x squared, negative 28x, that's negative 4 times 7x, negative 48. And usually what happens is the like terms end up going along the diagonal. Okay. By the way, this says any restrictions in domain or range. There's no restrictions in that one or in that one in terms of domain. You can plug in any numbers you want for x there. The range, the restrictions in the range, there will be a restriction on this one. That's going to be a parabola. So we'll talk about that restriction in just a sec. The final answer here would be 3x squared. We're going to add these. So 21x squared plus negative 4x squared is 17x squared. 36x plus negative 28x, or minus 28x, would be plus 8x. And we still have that minus 48. So here's our function. Restrictions in the range, if you were to graph this parabola right here, it winds up looking like this. And you can do this on a graphing calculator as well. It's going to have a vertex at about negative 3.5. So this is just a rough sketch. Okay, the range of this parabola would be y is greater than or equal to whatever that point is right there. So whatever the vertex is. And the vertex turns out to be, if you use negative b over 2a. That's how you find the vertex on a parabola. That would be negative 7 over 2 times, that's a is 1, so 2 times 1. So you get negative 3.5. You would then have to plug in negative 3.5 right here. So let's do that really quick. I'm just going to factor this to make it a little bit easier. So that is a factored version, and then negative 3.5 plus 3 times negative 3.5 plus 4, that's going to be negative 0.25. So this point right here is y equals negative 0.25. That is the range. Y could be anything bigger than that. So that applies to both of these now because we are composing them, or in this case we're actually multiplying them. And then how do you end up dividing? Here's what you would do for division. Actually, division is a little bit easier. F divided by g, well, f is this function, because that's up here again, there's f. G is this function right here. And that's all you do. There's nothing more that you have to do. That's f divided by g. Here's the only thing. This right here is going to give us a restriction on the domain. And what that means is you cannot have the bottom of that fraction equaling 0. Fractions can't divide by 0. So how do we figure out the restriction? We set it equal to 0 because we don't want it to equal 0. So we're going to find out what would make it be 0. And when we divide by 3, we get x equals 4/3. So here's the restriction. X can be anything except for 4/3. Why can't it be 4/3? Because if you plug in 4/3 right here, you would have that whole thing divided by 0, and you can't divide by 0. Alright, last thing we want to talk about before we do some examples is what does it mean to compose functions? And this is the symbol for it. You could write it as, some people call that fog of x. That little open circle there does not mean times. So they say that right here, f times g is different than f of g. That's how you read that, f of g. F of g can also be written as f of g of x. And what that basically means is instead of plugging in, normally we would say like find f of 2, and that would mean plug in 2 for x. F of g means instead of plugging in a number like 2, you actually plug in an entire new function. Okay? And then the domain of what you're plugging in becomes the range, the range of the function that you're plugging in becomes the new domain of f. So we'll see that a little bit more clearly with an example. Okay, and that's just restating what we said. Don't confuse multiplying with composing, even though the symbols look the same. Alright, so we want to find f of g, first of all. And I'm going to write this as f of g of x so it doesn't confuse people. And then afterwards we want to find g of f. So let's start with f of g. That's another way of saying find f of the following things. Find f of the following things. And here's an analogy I would use. It's kind of like you can pretend almost that these are phone numbers. In f, these are phone numbers. Actually, we'll do g because we're plugging in g. Let's say 8, 5, 10, and 9 were phone numbers. 15, 1, 14, and 0. Let's say those are operators that you're reaching. And then you take those operators and you go over here and you see if they can connect you with a real person. So phone number leads to operator leads to real person. That's kind of how a lot of phone systems are set up. Okay, so here's how this works. Here's how you find the composition. F of g of x means, let's see our outputs for g of x. Right here we want the outputs for g to become the inputs for f. We want the outputs for g to become the inputs for f. Or another way of saying that is we want to get the operators for f of x, for g of x, that means these numbers. We want to see if they can connect us with real people over here. Okay, so if I plug in, basically we take each of these functions, g of 8, g of 5, g of 10, and g of 9. We evaluate each of those and see what they give us. So what are these going to become? Well, we just look at see what are the outputs for each of those. So g of 8 is 15, so I'm going to put a 15 there. G of 5 is 1, I'm going to put a 1 there. G of 10 equals 14, and g of 9 equals 0. So all that we're doing with this problem is we're basically taking the inside function g of x and we're just listing out these outputs. 15, 1, 14, and 0. 15, 1, 14, 0. Those are the outputs for g, and now they are becoming the inputs for f. So now we need to look at f, and we need to see do these options right here show up as inputs? They were outputs for G, and they show up as inputs for F. Well, there's a 15, so F of 15 it looks like equals 11. Okay, F of 1, let's see, there's a 1 and it leads to 8, so 8 is the output for that. F of 14 is right here and that leads to 9, or that gives an output of 9. And then finally F of 0 is right here and that gives 13. So this right here, 11, 8, 9, and 13, that is the range of that whole thing that we just found, F of G of X. That's the range of that function. Okay, it's what we got when we plugged it in. What's the domain going to be? The domain is basically the original things that you plugged in for G. So the range is that. The domain is what we started with. Okay, what did we start with? We started with these numbers, 8, 5, 10, and 9. So the domain is what we originally started with plugging in for G. The range is what we finally ended with when we plugged in for F. Okay, so that's the first half of the problem. We found F of G. How do we find G of F? So let me put this down a little. And these are not the same, by the way. When it says if they exist, we're going to see why in just a sec. They sometimes don't exist. So G of F, which can also be written like this, G of F of X. Here's what this means. This means find G of these 4 options. And the reason I know there's 4 is because there are 4 coordinate pairs right here. So G of F of 1, F of 0, F of 15, and F of 14. Because those are the 4 numbers that they're giving us to potentially plug in for F as inputs. Okay, again, these numbers are coming from right here. 15, or F of 15, and sorry, F of 14. Okay, and it says if they exist. So let's see if they are going to exist. And by the way, those numbers that we just plugged in, that's the domain. The domain is going to be 1, 0, 15, and 14. Because those are the possible things that we could plug in at the beginning of the function. Let's see what the range is going to be. Okay, so G of F of 1, well, F of 1 turns out to be 8, so that's another way of saying G of 8. G of F of 0 turns out to be 13. G of F of 15 turns out to be 11. And G of F of 14 is equal to 9. So let's see if those outputs, those are the outputs for F, let's see if they exist as inputs to G. So G of 8 exists right here, it equals 15. G of 13 does not exist. If you look at these x coordinates right here, none of them are 13, so we'll say DNE for does not exist. You can't find that. G of 11 also doesn't exist because 11 is not any of those x values, so that does not exist. And this is why it says right here, if they exist. You can see sometimes they don't exist. Sometimes when you find this f value, it doesn't actually exist as a thing you could plug in for G. And then G of 9 is right here, that equals 0. So our range turns out to be 15 and 0. So actually what we need to do here is we need to exclude some things from what we originally thought was the domain. Because when we plug them in, it turns out that we can't actually use them. Okay, so let's verify 11 and 13, it looks like, are the things that we cannot, let's just double check there. Yeah, this has a typo right here. 11 and 13 are not in the domain, so our range would just be 15 and 0 because those are the only values that we got when we plugged those in, 15 and 0. Where did those come from? They came from 1, and they came from, what else? They came from this one, from 14. So we could say our final possibilities here, the domain would be 1 and 14, because that's the only thing that gave us values, and the range would be 15 and 0, because those are the only things we came up with as final answers. Okay, how do you do it when it's actual functions like this? For each pair of functions, find f of g, and then we're going to find g of f. And by the way, just to emphasize, these are not necessarily going to be the same, and in this case they won't be the same. So here's f of x, and here's g of x. And actually I'm going to change these to x's instead of a's, just to make it less confusing. So find f of g, that means find f of this whole function right here, find f of 4x. So that means wherever I see an x in this function, I'm now going to plug in this g of x function, which means plug in 4x, and then solve it out. So 2 times 4x is 8x, minus 5, and that's the answer right there. Okay, the domain and the range are all real numbers. There's no restrictions on what you can plug in for x for either of those. Okay, g of f will be different. So g of f is g of this function right here. G of f of x means g of, well, that's the f of x function. And that means g of x is this, it's 4x. Wherever I see an x, I'm going to plug in this value right here. So we get 2x minus 5. Let's multiply it out right here. 4 times 2x is 8x. 4 times minus 5 is minus 20. And you can see these are not the same. They do wind up being different. If they ever are the same, that's just a coincidence. There's no rule about how that happens. Alright, let's practice a couple more, and that's all that says right there. The order is important. Well, we kind of did this already with the first example. Let's just do some of these numbers. So h of g of negative 6, well, the first thing we want to do here is actually find out what g of negative 6 is. So that means wherever I see an x, I'm going to plug in a negative 6. So 4 times negative 6 is negative 24 minus 1, which is negative 25. So that means this number gets plugged in. G of negative 6 turns out to be negative 25. So we plug that in. And then here's our h of x function. So I'm going to plug in negative 25 right there. 4 times negative 25 is negative 100 minus 3. Gives us negative 103. Okay, let's do one more. Let's see which one of these looks a little bit harder. Maybe, they're not too hard, but maybe this one right here. A little bit tougher. So g of f of 1, well, obviously the first thing we want to do is find f of 1, so let's do that right here. F of 1 means wherever I see an x, I'm going to plug in 1. When we do that, we get negative 3, so that's what gets plugged in. So now I go up to my g of x function, I'm going to leave a blank space where there used to be an x, just a parentheses. And what goes in that parentheses is this number right here, because that's what we found. So g of f of 1 turned out to be the number negative 3. So I'm going to plug in negative 3 here. Order of operations, first we'll square this, so we get negative 3 squared being 9. And then minus negative 3 is like plus 3. Negative 3 times 9 is negative 27 plus 3 would be negative 24, and that's the answer. So just to point out, in general, when you plug in a number, you're going to get a number as an answer. And when you're plugging in something with x, you usually wind up finishing with an x. Alright, last example. When would you use this in real life? Here's a good example. New car dealer is discounting all new cars by 12%. At the same time, the manufacturer is giving a $1,500 rebate on all new cars. Mr. Navarro is buying a car, $24,500. Will the final price be lower if the discount is applied first, or if the rebate is applied first? So let's write two functions here. Let's call discount, we'll call that d of x, and let's call rebate, we'll call that r of x. And we'll do both. We'll say apply this first, see what happens when we apply the rebate first, and let's see when we apply the discount first. So first, obviously, we need our two functions. So d of x means we take our car price, $24,500, and we discount it by 12%. If you discount something by 12%, that means you take 12% off of it. That means 88% is left. So 0.88x. 0.88 times the original price represents a discount of 12%. Another way of saying it is, here's the original price, we're taking off 12% of the original price, and we get 0.88x. Okay, the rebate means that you are taking your price and you're basically subtracting $1,500 off of it. So those are our two, I'll just rewrite them over here, those are our two functions, and we want to see which one gives us the better deal. Okay, so let's try that right now. So here's how it looks. This is saying first apply the discount. So first apply the discount to $24,500. And by the way, that's the price of the car. They tell us up here. Where is it? Right here, $24,500. First apply the discount. So that means do the discount to $24,500 and then apply the rebate to that. This one says first apply the rebate to $24,500 and then do the discount. So these are going to be two different numbers. So let's find d of 24,500 first. Well, that's the same as taking 88% of, or 0.88 times 24,500. And what is that right there? That's going to be 21,500 $21,560. Okay, that just came from plugging in 24,500 there, and then R of 21,560, that means put that number in right there for X, and when you subtract 1,500 from that, what's that going to be? I think that's $20,060. So that is the amount you pay if you first take the discount. What happens if you do the rebate first? If you do the rebate first, that means you're going to do discount on whatever this is. So let's plug in 24,500 there. When you do that, you get 23,000. And then we need 88% of 23,000. That's this function right here. So 0.88 times 23,000. What's that going to be? 2760. I think that is, I'm not sure about this. I think that's 20, let me just double check here. No, this turns out to be $20,240. So we end up paying more money in this case. So we would prefer to do this. We would prefer to first have the discount and then afterwards the rebate. So that is section 6.1. Hopefully it made some sense on different operations with functions.